In this video, we're going to be covering spawners. And done. So today, we're going to build a proper spawning system. We're going to be looking at how to... Oh, okay, well, I can probably fix that. Oh no. In this video, we're going to be looking at how to build a scalable spawning system. Hang on, I turned it off. Why is it still... We need a spawning system that's reliable, easy to extend, and won't cause problems later. So let's get started. If you're dropping enemies directly into a level, they're still moving, still processing, whether or not the player is even nearby. That might be fine at first, but as your game grows, that starts to become a problem. So today, we're going to build a spawning system that's designed to scale. In my first project, I built a spawner pretty early on, and honestly, it did its job. It handled the behaviors I needed, it was flexible enough, and it let me move fast. But now I want to take that idea and turn it into something I can reuse anywhere. The spawner itself is simple. It's just a marker, a visible on-screen notifier 2D, and a timer. The node 2D could have been used as the root here, but marker 2D is essentially the same thing. It just adds a visual gizmo to the editor to make visualizing it a bit easier. It's the way that these pieces work together that makes the magic happen. So let's see it in action. Instead of placing an enemy directly in the level, I drag in a spawner. Then, I just assign what it should spawn. Now the enemy doesn't exist until the spawner decides it should, and the options in the editor allow me to tune the spawn behavior. This telly behaves like a standard enemy. It respawns when it's defeated, but only after the spawner comes back on screen. These spikers use a completely different rule set. They spawn on a timer with a random delay, triggered when they die or leave the screen. Yeah, these are a little hard to see here. I wonder if there's a spot that's a little more open. I've never actually checked up here. Oh, perfect. It's almost like this room was made for testing spawners. In here, we can clearly see the respawn behavior of the spiker. If I want, I can change the enemy type, and because it's a tool script, the preview updates in the editor. I even added a fallback sprite if it can't find the preview. Overall, this works. It gives me flexible spawning behavior, it's easy to use, and it solved the problem I had at the time. But by now, you may have spotted a bit of a problem. There are a few things to clean up, but let's take a quick look under the hood, warts and all.
That is one big pile of shit.
Okay, maybe warts and all wasn't the best idea. But to be fair, every experienced developer has code like this somewhere. It may not be pretty, but it worked. It's important to remember that your time is valuable, and chasing perfection at the cost of good enough usually is not worth it, as long as you're taking performance into account. This solved the problem it was written for at the time, but in order to bring it forward, it's going to need to do more, so now refactoring makes sense. So while past me goes off to clean this up, future me can talk about what a good spawner actually needs to do. Spawning is not just instantiate an enemy. First, it's about managing its entire life cycle. When does it exist? When should it stop existing? When is it allowed to come back? Second, it's about performance, making sure things aren't running when they shouldn't be. And finally, it's about game rules. What happens if an enemy leaves the screen? What if you want an ambush? What if multiple spawners share a limit? What about hazards that need to keep moving, even off screen? So a good spawner needs to answer a few key questions. What do I spawn? Where do I spawn it? When am I allowed to spawn it? Do I already have something else active? What happens when it dies or disappears? And what rules control all of that? Each spawner should handle its own local logic, but eventually, we'll also want something higher level. A global system that can enforce limits, coordinate behavior, and clean things up when the entire section unloads. We won't build that in full just yet, but we can add something simple and expand on it later. So now that we know what a good spawner needs to do, let's take a look at the refactored version. The goal here wasn't to make it clever, it was to make it clear, reliable, and easy to extend. Which prevents future me from having to reverse engineer this at 2 AM. The first thing I wanted to clean up was the configuration. The spawner should be easy to understand directly from the editor. What does it spawn? How should it respawn? Does it use the enemy's default behavior or override it here? If it uses a cooldown, how long is it? And if I drop in a different enemy definition, does the preview update correctly in the editor? To help simplify that process, I created a custom resource to hold the enemy data. Now, instead of the spawner's export variable pointing directly at the scene, it uses an enemy definition. That resource holds the enemy's packed scene, a preview texture, and the default spawn conditions for the enemy type. I can create one of these directly in the editor, pick exactly what the preview should look like. You can use an atlas texture to grab a single frame from the sprite sheet, and then save the resource to reuse anywhere that enemy is needed. So the spawner no longer has to dig into the enemy scene just to figure out what to display. And more importantly, it doesn't need to know anything about how that enemy is set up. It's all just data, which is exactly where it belongs. But because the data setup had changed, it left my level full of spawners that were basically blank. And this is exactly what makes the enemy definition resource so powerful. I created a definition resource for each enemy type, and since each one already contained the scene reference, preview texture, and default spawn settings, all I needed to do was select the right group, drag in the matching enemy definition, and move on. As soon as I started the game, everything was back up and running. The architecture cleanup was important, but this fundamentally changes how I can build levels going forward. I no longer have to specify the individual spawner behavior. I can simply place generic spawners, and then let the enemy data determine how they behave. Now for the preview itself, I didn't want to turn the entire spawner into a tool script just to make that work. So instead, there's a small, built-in tool script on a child sprite 2D that looks at the enemy definition, grabs the preview texture, and displays it in the editor. That script only runs in the editor, and it checks for changes to the definition. To keep it lightweight, I added a timer so it only updates a few times a second, which is more than enough here. Then, it only makes changes when it detects a new preview texture, and all of that logic is kept completely separate from runtime behavior, which means that the spawner stays clean, and the editor still shows exactly what it's going to spawn. With the enemy definition clear, the spawner script itself gets a lot easier to reason about. Internally, it only tracks a small amount of state. Does it already have an active instance? Is that instance currently visible on screen? Is it waiting on a cooldown? Is it limited to only a single spawn? And if this is a re-entry spawner, has it actually left the screen yet? That lack of clear state was one of the biggest problems in the old version. Not that it didn't work, it did, but too many of the rules were implied by how the script happened to flow. In the refactor, the spawner makes that explicit. Instead of spreading logic across the signal handlers, everything funnels through a single event handler. When something happens, like the screen is entered, the screen is exited, the enemy disappears, or a timer finishes, the spawner just requests a spawn check. Then, on the next frame, in a single deferred check, it asks one question: am I allowed to spawn right now? And outside of a debug option to disable spawning entirely, that answer is based on a small set of clear blocking rules. If this was a one-time spawn and it's already been used, no. If there's still an active enemy, no. If the cooldown is still running, nope. If the spawner isn't on screen, no. And if this mode requires re-entering the screen, but it hasn't actually re-entered yet, also no. Having these clearly defined checks makes it much easier to add or remove rules later. If every check passes, spawning is simple. Instantiate the enemy through the spawn manager, pass in the spawner's global transform, connect to the enemy's cleanup signal, and mark the spawner as active. The spawn manager has clear access to the entity layer of the game, so it instantiates the enemy there, which provides a huge bonus during debugging, since we can look at a single node in the tree to see every enemy. And that brings us to the other half of the job: Lifecycle Management. Spawning is only half the problem. The spawner also needs to know when that enemy is no longer considered active. In this version, that happens when the enemy signals that it's leaving the scene. From there, the spawner clears its active instance state and starts a cooldown timer, or immediately requests another spawn check, depending on the selected respawn mode. And that's what lets one spawner behave like a one-time encounter, another respawn only after leaving and re-entering the screen, another come back on a timer, and another simply respawn as soon as it's visible and available. And that's really what this refactor was about. Not changing the behavior I already liked, but organizing it so each rule has a clear place to live. So now the spawner has its own local rules cleanly. It knows what it can spawn, when it's blocked, and what event should trigger the next check. And later on, if I want to build a larger system on top of that, section cleanup, shared spawn caps, ambush groups, trigger controlled spawning, there's an obvious place to plug that in. And using this as a foundation, we could extend the same idea to things like hazards, lighting, effects, maybe even a cutscene. And more importantly, future me won't be stuck debugging this at 2 a.m. Thank you all so much for watching. If you enjoyed it, don't forget to like and subscribe. That's a huge help to the channel. And there's a lot of great content coming soon. I'm planning on a series building a vertical slice of a game based on feedback from the community, and using the project foundation we set up in the Git video. Let me know in the comments what type of game you'd like to see built. And if you want to see how this project actually started, click here for the full Git workflow and project setup. Thank you for watching, and I'll see you in the next one. Wait. Ow!